We need to look at finding the equation of a straight line, and you'll know this as y is equal to mx plus c. Though in some places it's ax plus b, and when you come to do things like economics at A level, you sometimes write it as something like that. But it's the equation of a straight line. Okay, here we have two lines. What do they have that is similar, and what do they have which is different? Well, we notice that they are both straight lines. But if we notice that this line here is steeper than the other line, and the other thing that we notice is that they cross the y-axis at different places. These two things are the characteristics that define and distinguish straight lines. So we've said this one is steeper here. What do we mean by steepness? Steepness is the gradient of the line. Okay, let's see if we can find the gradient of these four parts of lines. Okay, so gradient is how much we go up compared with how much we go across. So in this case, the first one, we go up 3 for every 1 that we go across. So the gradient is 3 over 1, which is 3. In this case here, we go up 3 for every 3 that we go across. So the gradient, now the letter we're going to use for gradient is m. So the gradient is 3 over 3, which is 1. In this case, we go up 2 for every 4 that we go across. So in this case, the gradient is 2 over 4, which of course is a half. In this case, we go up 2 for every 1, 2, 3, 4 that we go across again. Actually this is, we've changed the scale here, got to be a little bit careful on this. If we notice that this is 1 here, so in fact that is actually 1, isn't it? And 4 across, so the gradient is 1/4. Okay, doing the same thing again, but actually I'm going to do this one first here. Now if you notice, the line, when you look from left to right, is now appearing to go down. And how can we distinguish that from a line that appears to be going upwards? And we do that with a negative sign. Okay, so here we're going 4 across, and here we're going 4 up. So the gradient for this one is -4, because we're going 4 down for every 4 that we go across. So the gradient is -1. So the negative tells us that the gradient that is negative, the line is going downwards when we look from left to right. Now I just wanted to look a little bit more formally at how we can work out gradient. So I have been suggesting that we compare how much we go up to how much we go across. Now the up part is called the rise, and the across is called the run. So the gradient can be thought of as the rise over the run. I'm going to look at it in a little bit more formal way. Look at this coordinate here. The x coordinate is 4 and the y coordinate is 8. And for here, the x coordinate is 2 and the y coordinate is 4. Now I'm going to show this coordinate here as well, and that coordinate is 4, 4. So when I say that we go up here, that is the y value is changing from 4 to 8. So we're looking at the change in the y value. So change in y value and the run or the across is actually the change in the x value. So that is the change in x value. Okay, let's say we're given a pair of coordinates, two pairs of coordinates, and we're being asked to find the gradient between these two coordinates. How will we do that? Well, the best way of doing it is to draw a sketch. Now, it is a sketch, doesn't need to be accurate. Okay, so 1, 2, I'm going to place there. And 5, 10, I'm going to place there. And we're being asked to find the gradient between these 2 points. Okay, so we draw a little triangle. And we're going to find out the rise over the run. Now let me just put this coordinate in there. So this coordinate has an x value of 5 because that one's 5 there, and has a y value of 2 because that's 2 there, so 5, 2. So the gradient, which is the rise over the run, now that goes from 2 to 10, so that's a difference of 8. And the run, which is the change in the x values, is the difference between 5 and 1, which is 4, and the gradient is 2. And we also know that the gradient is positive because as we go from left to right, the line is going upwards. Now question 2, again I'm going to draw a sketch so I can see what's going on. 4, 3, why don't I put that there? 4, 3, and then 6, 9 I'm going to put here, and we've been asked to find the gradient between those 2 points. Okay, I'm going to put that there, and that gives us an x value of 6 and a y value of 3. So the gradient, m, I'm going to write it as, is the change in y values over the change in x values. Okay, so what is the change in the y values? Well, the change in the y values is that it goes from 9 to 3. So I'm going to write that down as 9 minus 3, the difference between those y values, the change in the y values. And the change in the x values goes from 6 to 4, 6 minus 4. So 9 minus 3 is 6, 6 minus 4 is 2, and that gives us a gradient of 3. And part 3 only has to be a sketch, so that's 4, 7, 16, 13 over here. So the gradient is the change in y values, that's 13 minus 7, and the change in x values, which is the run, is 16 minus 4, so m is equal to 6 over 12, and that is a gradient of a half, and it's positive again. Okay, so we're going to use that to draw these straight lines. So the first one, y is equal to 3x plus 2. Now this value here is the y-intercept. That's where this line crosses the y-axis. So I'm going to put that there straight away, and that in fact is our starting point. This number here is the gradient of the line, and the gradient is 3. Now if it has a gradient of 3, that means it has a change in y of 3 for every change in x, which is 1. And how can we do that? Well, let's have a change in x there, which is 1, and then let's go up 3, 1, 2, 3. So from there to there, we know that it has a gradient of 3. Let's do that again so we can carry on. 1 across for 3 up. Let's go from here. We're going to have to go 3 down, 1, 2, 3, and 1 down, like that. And let's continue from here, 1, 2, 3 down, 1 across. And let's continue, 3 down, and 1 across. And that is the line y is equal to 3x plus 2. Okay, in a similar fashion, y is equal to 2x minus 4. The negative 4 tells us where it crosses the y-axis, and we know that it has a gradient of 2, positive 2. Okay, so for every one that it goes across, it goes 2 up. For every one that it goes across, it goes 2 up. For every one that goes across, it goes 2 up. And now we have a series of points, all with a gradient of 2, and it passes through negative 4. Y is equal to negative 2x plus 6. So we know that it crosses the y-axis at 6 and has a gradient of negative 2. Now, gradient of negative 2, as we look from left to right, is going to go downwards. A gradient of negative 2, the negative tells you it's going downwards, and the 2 is just a gradient of 2. So for every 2 that we go down, we go 1 across. For every 2 that we go down, we go 1 across. For every 2 that we go down, we go 1 across. And so we have a series of points on this line, and we can easily draw it. And that is that line there. This one here, we know that it goes through negative 2. And this time it has a gradient of 1/3. So and it's positive, so it's going in this direction. So for every one that we go up, we go 3 across. So let's do that. Let's go 3 across. So starting at negative 2, let's go 3 across. 1, 2, 3, and 1 up. 1, 2, 3 across, 1 up. 1 down, 3 across. 1 down, 3 across.